the AI for Good Global Summit, convened by ITU, recognizes the joint responsibility of governments, the private sector, United Nations agencies, academia, and others to ensure AI reaches its full potential while preventing and mitigating harms.
And it's a moment that calls for action. And today I'm calling on each of you to use this summit to help the world to better understand what kinds of regulations, what kinds of guardrails we need to put in place right now. So together, let's make it innovative, let's make it safe, and let's make it responsible for all. Thank you very much.
Welcome to AI for Good, the leading action-oriented, global and inclusive United Nations platform on AI. Organized by ITU, in partnership with 40 UN sister organizations, and co-convened with Switzerland. The goal of AI for Good is to identify practical applications of AI to advance the United Nations Sustainable Development Goals and scale those solutions for global impact. In today's session, we're counting on you to use the live video wall feature to ask questions and post comments to help create an engaging discussion. We encourage you to stay until the end to chat, connect, ask questions, and network with our distinguished panelists and world-class AI experts in the neural network. It is now time to kick off the session and welcome our first speaker. The floor is yours.
Thank you, Anna. Thank you, Julian. Hello, everyone. Welcome to this Day 2 MathDance workshop. I'll share my slide. My name is CJ Chung, Professor of Computer Science at Lawrence Technological University, Southfield, Michigan, USA. I'm the founder of RobotFest, an autonomous robot competition, and the director of the Car Lab. My research involves connected and automated vehicles. So I will first hide the zoom control. Okay. Oh, it shows again. Goals of today's MathDance workshops are to learn basic concept of machine learning, deep learning, learn and sharpening your Scratch programming skills, learn mathematical foundations and mathematical equations, and we try to integrate math, AI, and Scratch coding to develop a MathDance game app. Today, actually, we are adding some music component to this workshop. Finally, we try to advance the quality education, one of the UN's Sustainable Development Goals. Okay, so this is our Day 2 project, which enhances Day 1 project. So I'll first play this YouTube video to see what we are going to do today.
Trained ML model is ready. You have 5 seconds for each question. Show me y equals x. Good job. Show me y equals minus x. Good job. Show me y equals minus x. Good job. Show me y equals 10x. Good job. Show me y equals x. Good job. Show me y equals 10x. Good job. Show me y equals 0. Good job. Show me y equals 0. Good job. 100% success. 35 seconds were taken. Let's dance.
So we are going to calculate the success percent, and also we measure the time taken to play this game. And if they are successful in every question, then we play or dance music at the end. This presentation file in PDF is available in Resources tab in Neural Net. Also, you can get the file at this URL. If you click on this PDF file, then you can get it from the RoboFest website. Also, if you are new to this workshop, don't worry, actually today's workshop will be covering almost everything we covered on day one. So day one file can be accessed here. So yes, if you are new to this workshop, I recommend you to download this file as well. Okay, so also it is recommended if you have additional monitor, it's better to open this PDF file to follow this hands-on workshop. Okay, I'll give you a few seconds to download and open the PDF file of this workshop. All right, let's go to the next slide. I would like to thank my assistants for preparing this workshop. They have reviewed this presentation, and they will be answering your chat questions, especially technical chat questions. So if you have questions, if something is not working, use the chat function to ask questions. They will be answering your questions. First, I would like to introduce Dr. Gwangchong Zhu. Dr. Zhu, can you introduce yourself briefly?
All right. Hi, everyone. Welcome. My name is Gwangchong Zhu. I'm a math professor teaching at Lawrence Technological University in Michigan, USA. Thank you.
Thank you. Julius, can you introduce yourself?
Hello, everyone. My name is Jerry Cesar. I'm a dual enrollment student at Lawrence Technological University. I'm a participant in their RoboFest competition, and I did research over the summer there with Dr. Chung.
Thank you, Julius. Gregory, can you introduce yourself?
Hello, everyone. My name is Gregory Aguian. I'm a high school student in the US, and I also did research with Dr. Chung at Lawrence Technological University.
Thank you, Gregory. Again, if you have technical questions during my presentation, please use chat function to ask questions. Also, it is recommended to use the full screen. The first agenda I would like to do is to review the concept of machine learning. What is machine learning? It's a subfield of AI. AI tries to mimic the intelligence of humans. And what's machine learning? Machine learning makes machines, models learn from sample data. So sample data can be labeled, unlabeled, or past experience. Today, however, we are using just labeled sample data. Then what's deep learning? DL, the special case of machine learning that makes machines learn from example data using brain-inspired algorithms. As I mentioned, we'll use only labeled sample data, so-called using supervised learning method. Okay, so yes, this workshop is about creating apps to recognize your hand pose, like this one represents y equal to x. This one represents y equal to minus x. By the way, I recommend you to roll up your sleeves to recognize, models can recognize better if you roll up your sleeves, because we are using just a few samples this time to train to save time for the training. So I recommend you to roll up your sleeves to get training data. This pose is for y equal to 0, and this pose is y equal to 10x. And this is a concept of machine learning. We will collect around 50 sample images representing y equal to 0. Then also we collect sample images of y equal to x. The same thing for y equal to minus x, y equal to 10x. In addition, we need images that does not show your hand. I label that as none. So using those images, we train a deep learning model. It'll take some time. After the training, if you show this new image from our Scratch app, and we send this webcam image that has not been used for the training, the trained deep learning model can give you the answer. Like, oh, this belongs to y equal to 10x class. So this is the big picture of deep learning, machine learning process, what we'll be doing today. Another big picture. So after collecting sample data with 5 classes, we use Google's teachable machine to train a deep learning model. After the training, we connect this deep learning model to our Scratch app. For developing Scratch programs, we'll be using machine learning for kid site. We are not using the standard MIT's Scratch site. We are using ML4K site. And your Scratch code will send your webcam image to the model trained. Then this model will answer the label of the webcam image you sent, as well as the confidence. We say this step to ask the trained model with unseen image, and the trained model will return back with the correct answer. And we call this step as an inference. Tools to use today. We are using Google's teachable machine that is using pre-trained mobile network. And we are using machine learning for kids website. And I want you to bookmark them because we'll be using both sides quite often today. Okay, now let me introduce Scratch coding part 2. Okay, we did similar coding on day 1. At the time, you were using logical AND operator. Now we are using logical OR. What will you hear from this code? So when the green flag is clicked, set a variable called recognized as to cow. Then set certainty to 45. Then we check whether recognized as variable is same as cow, which is true, or certainty is greater than 50. Oh, it's not true because the certainty set now is 45. But if you use logical OR operator, if either is true, either is yes, in this case, recognized as cow is yes, then you will hear the moo sound. Okay, that's logical OR operator that you'll be using to develop today's app. Next, we are introducing a timer in your Scratch code today. Timer can be found in sensing category, a special variable that timer is a special variable that keeps track of time after the reset. We used join on day 1, but we'll be using a lot of joins today. Join combines the two values together and reports the results. Okay, so this is something I want you to actually practice today as task 1. When the green flag is clicked, create a variable called counter and set the counter to 0. Then we set the timer. Then do something like repeating 1 million times to change the counter by 1. So it will take some time. So then after completing this repeated task, and I'm curious, how long it took to count from 1 to 1 million. So I'll ask Scratch Speak to tell the time spent for this task. Also, I would like to see the value of this counter after repeating 1 million times. Okay, so this is something, let's practice base 1. And in developing the game, the concept of timer is important. So let's do it. Okay, so I want you to first go to machine learning. So machine learning for kids, you search, then you'll find something like that. And I recommend you to click on pre-trained models. Then you will see this web page. We'll be using, TensorFlow, open our TensorFlow model when we use the pre-trained model, but just to test basic Scratch code, click on this, get started. Then usually today we are not using this cat sprite, so delete and make this canvas workspace bigger. Then click on event and let's declare a new variable variables, make a variable, and let's use counter, then set counter to 0, then reset timer. Yes, this is an important concept. So this Scratch, we have a timer and reset the timer to measure the time taken after resetting the timer. Then we introduce a big loop, repeat 1 million times, 1, 1, 2, 3, 4, 5, 6 zeros. Then what I want you to do is set, not set, change the counter by 1. So count the variable counter will start from 1, 2, 3, 4 until 1 million. Then we are interested in the time taken to do this repeated task. So we would like to say the number. So to do that, click on Scratch extension to add, choose text to speech, and you'll have this block speak. Here, I want you to say 2 things. So we need to join the count. Click on sensing. I want to first speak the timer after the reset, and some explanation like seconds taken. All right. After doing that, I can actually copy this block by right click, then duplicate, then you have another speak. This time I want to speak the counter value is variables counter, right? So let's run this code.
0.694 seconds taken. The counter is 1000000.
Oh, this system cannot, read 1 million. Instead, it says 1000060 zeros. Anyway, I play again to hear clearly about the time taken for this 1 million repeats.
0.727 seconds taken. The counter is 1000000.
Yes, to repeat 1 million times, it took 0.7 seconds on my computer. All right? So, yes, this is something important to use the concept of resetting timer and the way to use the timer. Okay, now let's go to the next slide. Another important concept today, I'd like to introduce broadcast and parallelism, whereas repeat until with empty body. So this is what we'll be testing today. We have 2 parallel scripts. Each script runs independently and simultaneously. So important one is this broadcast countdown. So this script is send a message to another script, and the message name is countdown. So this independent script, if it receives countdown, then it repeats 3 times by playing mew sound, then decrement the counter by 1. So let us test this code. So I'll be just using the same and Control Shift, the control. All right. So this is an important concept in computer science to run 2 programs at the same time. Okay, so set the counter to 0 as we did before. Then we introduce a broadcast message to instantiate another script. To do that, we go to Events, find broadcast message, and we can name the message. So I'll name the message as countdown 5. I'll use underscore. And say OK. Then you'll find another block when I receive message. So here choose countdown 5. In this script, I'll be decrementing the counter by 1. So to do that, I will be using repeat 3 times to decrement the counter. I mean, while playing mew sound, then decrement the counter. So to play mew sound, meow sound, yes, click on this sound tab. We are working on this code tab. Click on sounds. Then we don't have the meow sound, so we need to add that and choose this sound, then type meow, then you find meow here, then it's added, then you can use it in your coding. So go to sound. Yes, now we have meow sound until done. Then we need to change the counter by -1. That means we'll be decrementing counter by 1. So this independent task is decrement first playing meow sound, then decrement count by 1. Then repeat 3 times. That means after the repetition, the counter will become 0. Another script has started this script. Then this is keep checking whether the counter becomes 0 or not. So to do that, we can use wait until, but I'll use wait until with antibody. So this code is checking the termination condition. If the termination condition is not met, then don't do anything. It's because it has antibody. So repeat until counter becomes 0 or counter becomes less than 1. So what I'll do will be click on operator. I'll be using less than. Counter is less than 1. So repeat until we specify the ending condition. So if this is not met, don't do anything. Just repeat until this is met. Then, if this condition is met, then exit the repeat until do the next block. So let's do just say hello. Okay. So can you guess what this code will be doing? When this is executed, you'll hear one meow sound, then counter becomes 2, then another meow sound, counter becomes 1, another meow sound, counter becomes 0. Then this independent script is keep checking whether counter becomes less than 1, right? Immediately after counter becomes 0, this condition is met, then you will hear hello. Let's run it.
Hello. Hello.
So you didn't just count down, repeat until counter is less than 1, speak hello, decrement the counter by -1, down, play mouse down. Yeah, let's test once more.
Hello.
So for some reason, this is not checking correctly. You are supposed to hear hello after. So let's test this. Until done, counter by -1, clicked, counter to, oh, so, I found an error. So in the beginning, the counter was 0, so this was met, so you heard hello immediately. So the counter I was planning to use 3. Okay, so then let's rerun.
Hello.
Okay, so counter was set to 3, then counter decrements by 1 by this independent script. When the counter becomes 0, this met the termination condition of this repeat until, so you heard hello. Yeah, let's rerun.
Hello.
Yes, so yes, this technique we'll be using for our app development today to give 5 seconds for each question. If the user does not show the right pose for the target equation, then something like this code will, say, oh, you don't, you used all the time for that question, then the next question will be asked. And this is simple code, but I want everyone to test, to feel the concept of script parallelism. Okay, now let's go to the next slide about teachable machine. Actually, this is the slide for me. It's time to turn off the Zoom camera. So I'll turn off the Zoom camera because I have only one camera and all the tasks here are using camera. So I'll hide this control. Right. So this is the steps to use your trained TM model in Scratch. To do that, first you need to train the model. To do that, go to Teachable Machine, then you'll see Get Started button. Today, I want everyone actually to do this step again. If you participated in day 1, already you have this MathDance1.tm file, but to reinforce your learning, I want you to start from scratch. You'll be training after collecting images for 5 classes. Then we'll be double checking whether all the images are correct. Test after training, test thoroughly, and save the teachable motion file, project file as MathDance2.tm. After doing that, we export the model to the cloud. For this step, just click this Upload My Model button. Then sooner or later, you will get an URL, copy it. Then I recommend you copy it, and it is strongly recommended to paste it to a notepad. Then close teachable machine. Make sure this webcam is not used by this teachable machine. After doing that, go to ML4 Kids site and click on Open a TensorFlow model at the bottom. Then paste the URL, copy it in step 7 above, and click on Open Scratch. Then you will see something like this, and make sure you find this TM My Image Model is inside the Scratch. I would check whether it contains all the 5 classes. Then import video sensing and text-to-speech extensions. Then first remove the cat sprite, name the project file as MathDance2, create this code to test the connection between your Scratch and the trained model is established. And it is always good to save the Scratch file at this time. Okay, so yeah, let's do the live testing. So click on go to teachable machine with google.com, and you'll see this web page. Click on get started. Then you'll see image project, audio project, post project. We will cover post project at the end of today's workshop, but now we are using this image project. If you already have a TM file, you may not open it here, but I recommend you to redo today image project. Choose standard image model. Then you see this window. Then first class as y equal to 0. Then click on webcam. So I don't see the webcam image. If that happens, I usually restart the browser. Okay, leave the site, and yeah, it's better to completely restart the browser. So, okay, I will restart. Okay, just a minute. So we'll restart the browser if you don't see the camera image. Oops. It's not. Let me do it. Then I'll be doing teachable machine with google.com, get started, image project, standard model, and class S0, click on webcam. Okay, now I can see my image. Then to collect images, sample images for y equal to 0, first make a pose like this, then hold this button, hold to record. So I'll be clicking this to collect 2 samples, keep on clicking, sometimes further, sometimes closer, to collect around 50 images. Okay, that's enough. And also go through all the images, whether unwanted images included in this y equal to 0 class. Class 2, y equal to x. Click on webcam. And yes, this y equal to x pose. So hold, closer, further. Okay, that'll be enough. 56, again, check all the images. The third class, minus x, I recommend you to use minus x instead of dash x. Minus x is like this. And again, it's better to roll up your sleeve. For the better recognition. Minus x. Closer. All right, then double check all the images. Okay, sure, yeah. Then class 4 is 10x. It's like this vertical pose. Closer, further. That's enough. Then none, in case you don't show any hand. Okay, so this is the default case. None, so go to correct none images around 50. And double check whether all the images okay. Okay, now it's time to train a deep learning model. All you need to do is just click on train model, thanks to the nice tool provided by Google's Teacher Machine. It takes around 20 seconds to train. All right, then you will see already the trained model recognize the current image as none because I don't show any of my hands. If I do y equal to 0, the confidence is 100% with this image. How about y equal to x? Yes, it's almost 100%. How about minus x? How about 10x? X? Okay, so I think it'll be okay, but I'm not quite sure about this x, so I'll add some more images for this x. So here, and let's add some more, like okay, I added just a few images for x. After adding, you need to retrain the model. Okay, let's test this. Seems like it is slightly better. Right. So make sure you have a good model, very reliable, accurate model, to classify 5 different classes. The next step is to export the model to the cloud. So click on this button, export model. Don't change any option, just click on upload my model. It'll take some seconds until you get your shareable link. Okay, so now we have it. So click on this copy, then it is highly recommended to save the URL into notebook, into notepad. So I usually do this way, copy, then that has 4 mathematical equations, and I took these images at home. I'm now at home, and date 25th, 24. So that's a good information for you to reuse your model later. Okay, then I'll close this, I'll close the camera, and before I leave, I recommend you to save, download your project file, and save it to a location that you know. So I always save it under TM. So I type, this is MathDance 2. Okay. MathDance, Math, Dance 2, day 2. Save it. All right. Here, I have the URL in my clipboard. Now it's time to go to this machine learning for kids site. Go down, 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 find TensorFlow, open a TensorFlow model. Then you will see this dialog. Paste the URL here. Make sure type of model is image or pose, open Scratch. Then you will see, this is most important thing, click on this TM My Image and click on this one to make sure that the trained model has 5 classes, 0x, minus x, 10x, none. Okay, seems like we made the right connection. For this app, we are not using this Scratch cat, so remove sprite 1. We are writing the code on this backdrop stage. I usually make this smaller. Then let's test the connection between this Scratch app and the trained model. So the simplest case would be when green flag is clicked, I would like to say, so text speak, then click on my TM My Image. So go to control. At the end, you'll find wait until. So wait. It takes some time to make the connection. So wait until machine learning model is connected. Machine learning model is ready to use. If not connected yet, then it will wait. After the connection, it will say model connected. All right, let's test this.
Model connected.
So you heard model connected. I'll play again.
Model connected.
Okay, it is always recommended to have a comment. So I usually copy the URL of the model. Also, it's good to say this is done today, September 25th. Right, so also change the project name as MathDance 2. Right, then it's always good to save this file. So I'll save to your computer, and I always use, okay, Scratch folder, and this is for AI for Good program. So I'll say MathDance 2. So I already had it, but I'll overwrite. So currently, I have a simple program that is using the model we trained just before, and we tested the connection. Right. So leave this program up, and let's go back to our slide. Okay, so we have completed up to here. Now I want you to see the summary steps. We need to finish 16 steps. And now let's start hand MathDance game app development, professional version on day 2. So let's rewatch this day 2 project.
Trained ML model is ready. You have 5 seconds for each question. Show me y equals x. Good job. Show me y equals minus x.
So you
Good
will
job.
see
Show me
success
y equals
count
minus
is
x.
increasing.
Good
Now
job.
3,
Show me y equals 10x.
you will see
Good job.
the
Show
label
me y
and
equals
confidence
x.
from the trained
Good job.
model.
Show me y equals 10x. Good job. Show me y equals
Also, you
0.
hear the pop sound
Good
to
job.
count
Show me y
5.
equals 0. Good job. 100% success. 35 seconds were taken. Let's dance.
It took 35 seconds. Actually, my personal record was 34 seconds to complete 8 questions. Okay, this is summary, what we have done and what we'll be doing. We have collected 5 classes. Each class represents a mathematical equation. And using those images, we trained a deep learning model and we exported to the cloud. And your Scratch coding just tests the connection between this and the model. But we are going to send the current webcam image, and the trained model will return label and confidence to your program. And we say this step as inference. Let's summarize new features of day 2 project today. First, if the user's hand pose is not recognized as the target equation within 5 seconds, your program is supposed to speak timeout and ask next question. Second, your code is supposed to measure time taken in seconds to complete all the questions. Today, during the debugging and testing time, we'll be using 4 questions. After completing all the program, we'll be using 8 questions. Third, we will calculate the percent of correct hand pose answers. For example, 6 correct out of 8, then you will hear 75% success. And play a music to MathDance if all the questions are answered correctly. So for new things to do today, and we'll introduce more variables. So label is the class name, recognize the model, and it's and together with the confidence. We need an index variable I to randomly select the question and n questions, number of questions, target equation, decided at random. Then we have another variable, target recognized. This variable can be either true or false or yes or no. So in today's program, we'll use yes or no as TG, target recognized. We also introduce another variable, seconds left. This is for counting 5 because we give only 5 seconds for the user to make a correct pose. Also, to calculate the success percent, we have success counter. We need to create a list, math list, and to make program more structured, we introduce 1, 2, 3 new my blocks. The first one is pick one equation and ask the question to the user, inference and check, and game ending. Okay, so let's have a stretch break. I'll play MathDance. Then after 3 minutes, we are resuming this workshop. Okay, let's begin. Let's begin the program. So we are developing slightly larger code today. So this part is our main code. Then we have 1, 2, 3, 4 my blocks. The first one would be pick one equation and ask it. Then second one would be initialization. Third one would be inference and check. And we have a script to count 5. Then we have a new my block called game ending. All right, so we need to do those for my blocks and one script instantiated by a broadcast message. Okay, I'll open this one, MathDance 2. All right, so what I would like to do first is to create initialization my block. So click on my block, make a block, initialize. Okay. And yes, initialize here. So first we need to turn on our webcam. So okay, so we don't have text speech. So we need to add extension video sensing. Then you'll find video turn on, set transparency to 0. You click this, okay, now so I can get a good webcam images. Then we need to create a list to hold all the equation names. So click on variables, make a list, and let's name math list. Then we need to clean up before adding our stuff. So we would like to store all the class names. To do that, click on this model and get this report block. Then I duplicate, then duplicate 2 together. So we need 4 additions. Select 0 to math list, then select X to math list, select -X to math list, select NX to math list. Okay. After adding 4 math equation names, then yes, let's create another variable to calculate the number of questions for the game. So make a new variable, n, which means number of questions. Okay. So set number of questions and questions to the size of math list. But I write to the number of questions by multiplying some number to the length of math list. So I'll first put it here, go to operator and find multiplication. Yes, then put length of math list. And I used to use 2, but during the debugging and testing, I used just 1 to save time. But at the end, I will change the number to 2. Okay. After defining number of questions, for this professional version, I want you to create another variable called success count. but we need to announce the success percent at the end. So success set success counter as 0 in the beginning. Then, of course, we need to connect to the model, which is this. So I'll just move it. Then wait until the model is connected. If connected, your code will speak model connected. Then you have 5 seconds for each question. You have 5 seconds to show the correct equation pose for each question. Then, important thing for this version, we need to introduce a timer. So, click on this sky blue color for sensing blocks, and you'll find reset timer and put it there. Yeah, that's the initialization step. Let's test it. So what I would do would be, I'll just move it to right, then I'll call initialize. So my block initialize. Okay, let's test whether our initialization is okay.
Model connected. You have 5 seconds for each question.
Seems okay, right? Then using number of questions, yeah, let's select equation name at random. So you'll be repeating 8 times. So repeat, instead of putting 8, we'll be using variable n questions. So currently, in this case, n questions is 4 because we are using just the size of the list. We'll repeat this and let's select at random. In order to do that, we need a random number. So we need to create a variable I representing index and set I to a number chosen at random from 1 to length of math list. So currently math list, the length of math list is 4. So I will be either 1, 2, 3, or 4. Then using this I, let's get the name. To do that, and save it as target equation. So that means we need to create another variable, target equation, just Q. So set target equation as the item from the math list indexed by I. So I will be here, right? After doing that, I want you to speak. So to make sure, speak the target equation. So to do that, I'll have join saying, show me y equals to the target equation. So variable target equation, yes. All right, so yeah, let's test.
Model connected. You have 5 seconds for each question. Show me y equals x. Show me y equals 0. Show me y equals 10x. Show me y equals minus x.
Oh, so this time all element was chosen at random. Okay, so it seems like, yeah, the initialization and the first part of this code is working well. But I would like to simplify and shorten this main script. So I'll create another my block as pick one equation and ask it. Pick one equation and ask it. So that's the name of the part for doing this. So that means we need to use it like that. Okay, now time to do the inference. So let's create, I just move to right. Let's create another my block, inference and check. Inference and check if the user shows the correct pose. Inference and check. So here we need some new variables, such as what we did last time, label, and another variable called confidence, and set label as null, because we don't have any inference done yet. Confidence, that means it should be 0. Then we need another variable called whether target is recognized or not. TG recognized or not. So in the beginning, target has not been recognized yet. We didn't ask anything yet. So target recognized as no, not recognized. Then let's do the inference. So that means the label can be by sending webcam image to the model. We are sending webcam image to recognize. Then the model will return a label of the image. And that label is stored into our local variable called label. All right. Then also we need to get the confidence by using this report block by sending webcam image. So label will have the label of the current webcam image, and confidence will have the confidence of that webcam image. I mean, recognized as this label. Okay, then we need to check whether the current label is same as the target label. If same, then we have a variable called target recognized, and we need to set that variable as true or yes. So we need an if statement here, if block. If target recognized is same as the label, that means we need a operator is, but there are two cases, two conditions to check, because if the confidence is low, then we don't regard that as completely recognized as the target label, target equation. So we need an AND operator. The first part will be label is correct. The second part is the confidence is greater than a certain level, certain number. So first, yes, we need to use the variable label if the label is the target equation and the confidence is greater than 75. If that's true, if both are true, then we set target recognized as true or yes, target recognized as yes. Okay, so I think inference and check. My block is completed. Yeah, let's use it. So after picking one equation to ask, then we need to call this for the first webcam image. So inference and check. If the very first webcam image is not the target image, then we need to keep doing the inference. That means we need to repeat until block. And if not recognized, we have to repeat until the target is recognized. So we can do operator target variable target equation. No, not target equation. Target recognized is yes. True. Okay. Okay, so if target is recognized, we need to say something. So, okay, text speech, speak. Good job. All right, let's test this code.
Model connected. You have 5 seconds for each question. Show me y equals 10x. Good job. Show me y equals minus x. Good job. Show me y equals 0. Good job. Show me y equals 10x. Good job.
Okay, then end of the program. So you don't need anything else. Okay, so inference and check is working well. So I just move to this side. Okay, so I'm going to go slightly more down, then I put it here. Now, next thing to do is the most important topic on day 2 to instantiate another parallel script that checks whether 5 seconds has elapsed since the question. Okay, so to do that, as we did before, we need to create a new broadcast message. So I put it here before inferencing. So the message name is, in this case, start count 5. Then you'll find when I receive message here, I need to select start count 5. So this broadcast is instantiating this parallel script. So what to do in this case is, yes, we need to first create another variable called seconds left. So step left. And we will set seconds left here as 5 because we'll be counting 5. Then we need to repeat to decrement the counter. So we need a control and repeat until, in this case, we need OR condition. We have to count down until target is recognized or seconds left becomes 0. That means we need OR operator right here. So we need this equal additional equal. So the first condition can be, we need to stop counting when the user shows the correct target equation pose. So what we need to do to be variable target recognized is, yes, target is recognized, then we need to stop repeating decrement in the counter, or counter becomes 0. So second left becomes 0, then stop the repetition. Inside this repeat until we need to actually measure 1 second. To do that, click on Control, wait 1 second. Then we need to decrement the counter. So variables, change seconds left by -1. Also, it'll be good to hear something. So we'll be playing pop sound. So sound, we find pop. Okay, so I think this script, parallel script, is all set. Now let's use it. So this will broadcast to start this script. Then it will inference and check whether target is recognized. Also, if the user didn't show the correct pose, then you need to do something else, saying, oh, timeout, something like that. So anyway, you have to terminate this repeat until. In this case, we need another OR operator. So introduce this OR. 2 cases. We terminate this loop, whether target is recognized, or the counter seconds left became 0. So we need another equal seconds left. So variable seconds left becomes 0. Okay, let's check whether anything is missing. Okay, this. All right. Then, so we need to say good job or timeout. So we need if else block. So control, find this if else outside this loop. Right? So if we say good job when the target is recognized. When target is recognized, then say good job. Then don't forget to increase the success counter. So variable to go to change success counter by 1. If not, this loop was terminated, but target is recognized. It's not yes. That means this case, seconds left was 0. In the case, you need to say, oh, you're timed out. So here.
Model connected. You have 5 seconds.
So type timeout. Okay, so let's test.
Model connected. You have 5 seconds for each question. Show me y equals -x.
-x.
Good job. Show me y equals x.
I wait. 1, 2, 3, 4, 5.
Timeout. Show me y equals 10x.
10x.
Good job. Show me y equals x.
I'll not do that. 2, 3, 4, 5.
Timeout.
Okay, it seems it's working. Now, the last, my blog. So my blog, game ending. Okay. So what I would do would be, I'll be moving this down and game ending here. All right, so game ending, we need to do three main things. So we need to speak the success percent. So first text to speech, speak. Then we need join. To calculate success percent, we need to divide as well as multiply and variable success count multiplied by 100 to calculate the percentage, divide by number of questions. And we say percent success. Then we would like to tell the time taken only the user achieved 100%. To do that, we need a if. If, then we need equal logical operator. And if success count is same as number of questions, then yes, we need to speak. We need to speak. Join. Actually, we don't need that. Okay, so let's throw them away. We need to join timer because we reset the timer in initialization, and we need to use the timer to get the time taken since the reset join timer, and then it should be something else. It should be something like seconds taken. Seconds taken. Then, since we achieved 100%, let's dance. Okay, so for the dance music, I want you to click on sound, and you don't have any dance music here, so you search and type dance, and you could choose either of them, but I like the second one, so I'll choose this one. Then play the music. So play sound until done. Then celebrate. Then still, our counting down script is running. So I recommend you to actually stop everything, every script at the end of this game ending. So stop all to add here. Okay, let's test.
Model connected. You have 5 seconds for each question. Show me y equals 0.
0.
Good job. Show me y equals x.
X.
Good job. Show me y equals 0.
0.
Good job. Show me y equals x. Good job.
It doesn't say anything because I forgot to use it. I defined what I didn't use in main. Oh, my. So game ending here. Oh, let's retest. Oh, sorry.
Model connected. You have 5 seconds for each question. Show me y equals 0.
0.
Good job. Show me y equals x.
X.
Good job. Show me y equals 10x.
And X.
Good job. Show me y equals x.
X.
Good job. 100% success.
Yeah.
18.059 seconds taken. Let's dance.
Yes. Yes. Let's do that.
Hey,
Okay, so I think we are done with everything, but we have to clean up those. So we don't need those variables displayed. So I mean, those numbers are good for debugging your code, but at the end you don't need it. So click on here, then I will keep confidence. No and questions. I don't want that. Also, I don't need a math list. So only two variables are displayed. All right. And also, yeah, now I want you to play different song downloaded from the web. On my slide, you can find the music file, picky.wave file. You can download it and you can include your Scratch app. So to do that, I want you to click Sound tab, click on this, upload sound. Then under my downloads folder, I downloaded that file, picky.wave. Just select. Then you have picky music. Then go to code and change. Oh no, not this one. So here. Change to picky. Okay. Then make sure the file name is MathDance 2. Then it's time to save to your computer. So yeah, I'll rewrite. That means change the file name as the same file name as before and save. I'll be replacing the old file. So I made sure to save my code. Then let's test the last test.
Model connected. You have 5 seconds for each question. Show me y equals x. Good job. Show me y equals 10x. Good job. Show me y equals 10x.
I'll not show this time. 2, 3, 4, 5.
Timeout.
Timeout.
Show me y equals x.
X.
Good job. 75% success.
Yes, 3 out of 4. And if not perfect, then they don't ask you to dance. Right? So, by the way, I forgot one thing. So for the full version, I was planning to use 8 questions. So that means instead of multiplying by 1, I would like to change it to 2. And let's test again.
Model connected. You have 5 seconds for each question. Show me y equals 10x.
10x,
Good job. Show me y equals 10x.
10x,
Good job. Show me y equals x.
x,
Good job. Show me y equals x.
x,
Good job. Show me y equals minus x.
minus x,
Good job. Show me y equals 0.
0,
Good job. Show me y equals x.
x,
Good job. Show me y equals 0.
0.
Good job. 100%
Wow.
success. 31.559 seconds taken. Let's dance.
Okay, so I want you to practice this code. Then I have assignment for you if you are interested in. So let's go to the next slide. Okay, so we completed this main, this initialize, inference and check, and parallel script, game ending. Now, I'd like to introduce more equation graphs, such as y equal to x squared, y equal to negative x squared using this pose. However, if you are working alone, you may need a USB foot pedal switch like this. or it's a good team project for students to work as a pair. Then additional function could be y equal to absolute x, y equal to negative absolute x, y equal to 2 to the power of minus x, y equal to 2 to the power of x. So self-task after today's workshop, add 6 more equations to the app. Total, that means total 10 equations. Create a video using screen recording software. Then send me a video link. Then you'll get a certificate of completion, or I should say completion in PDF file. 2 agent on the left, MathDance animation. So this was done in 2017. Students from University Prep Science Math School in Detroit. Watch this, what they did. At the time, we had a circle. And according to our research, students improved their math scores after participating in this workshop. In 2018, we added art component by drawing as well as composing music. Let's watch. This is the music they composed. Okay, today, yes, we are doing something like this. Minus x, like 0, 10x, absolute x, negative absolute x, x squared, negative x squared, x to the power of x, x to the power of negative x, and we repeat. Okay. To do that, yes, you need some more scratch skills. So we are creating 10 costumes, as you see here, 10 images for each equation pose. And also we are using, this code you can download from this link. We don't have time to do a live demo. Then you need to analyze the music file. So I was using Piki Dance music that has 4 measures. Each measure took 1.5 seconds. That means 0.475 seconds for each bit. If you know this, if you divide, so this musical notation means that you need to repeat this many bits per minute. So you need to calculate the tempo, and the result would be 126.32 tempos. So it's like in the range of allegro in musical term. So the music file, Picky Picky Dance music file can be downloaded from here. Okay, then you can write a code, something like this. To synchronize, you need to use the broadcast message. I named the message as measure because for each measure, we ask this script to repeat 4 times. Because why 4? Because the music file has 4 measures. For each measure, I want to show each pose. So yeah, so this is the scratch. You can set the tempo of the dance to 126 quarter notes per minute. Then I play prelude, create function list, switch the costume to the last one, because we are using next costume. To show the first one, you need to position the last costume. Then repeat 5 times to play, 10 poses twice. Then broadcast for each measure. Then play the music. After the music, play clapping sound. Then stop every program. But to do for each measure, you repeat 4 times. For each repeat, show the next costume, which means next pose, and get the function index. So this will increase 1, 2, 3, 4, 5. Then it becomes 11. But to access the list, you need to change. If this index becomes greater than 10, then reset this function index to 1. Then say the function index. Then rest for 4 bits, because this script is to show the function name, equation name. During that time, you have to wait. Anyway, this synchronization technique will synchronize the music and the display of costume. And this is the music. We play la ra, da ra ra in B flat. And this is the way to play the music. And this is the function block to make a list of 10 equations. Again, you can download this code, and I want you to test. The last step is pose models. So far, we have used image models. An example is this image. But we can also use pose models. An example is this. You will see the points of my joints in my body, including 2 eyes, nose, and ears. So if you use pose, this will excel in tasks requiring human pose estimation with real-time processing capabilities. This require more data for, I should say less data for training compared to general purpose image models. However, it is sensitive to variations in lighting and so on. So to use the post model, go to teachable machine, select this post project, then the rest are the same. However, you will see the the location of your joint points connected with lines. Make sure you have correct poses. Then train, and you can test. After the testing, you can export the model to use this model for your application. So as an example, I was using just left up, right up, or no ends, 3 cases, 3 classes. When you collect right hand on samples, make sure this is connected and your wrist is recognized. For example, this one, bad samples that you need to delete, it doesn't detect my wrist. No detection. So in that kind of samples, you need to delete. The same thing, left hand up samples, good ones, bad ones. And this is the program I'll be demonstrating. So same idea, turn on, set transparency 0, connect, then repeat forever. Inference, if the label is left up, say your left hand is up. If the label influenced is right up, your right hand is up. And check, confidence is greater than 75 for each case. Okay. So what I'll do will be the testing of that code. So I use this and I just load and I store this into Scratch for this workshop. And the name of the program is left, right, hand up using pose. So I open this. Say okay. So yes, this is the code I just showed you. I just run.
Model ready.
Oh, I don't like this advertisement. Okay, so
Your right hand is up. Your left hand is up. Your right hand is up.
okay, so this is the sample program you can download from my PDF handout. Okay, let's go back to the slide. All right, so we just demonstrated this. I strongly encourage you test post models. Then you can do something interesting projects using post models. You can develop an app to count the number of correct sit-ups, correct push-ups, correct squats. Okay, so for example, this is not a good squat. So that means train only good squat poses, then count. If someone does this, the counter will not be increased. The same thing for push-ups and sit-ups. Okay, so this is the end of my presentation. And I would like to thank Dr. Do, Julius Ager, and Gregory. And I care about the license information. This is, this information is for everyone around the world using CC BY 4.0 license that allows anyone to share, adapt, and use the license to work for any purpose, even commercially, as long as you give appropriate credit to the original creator. And I would like to thank everyone for participating in this MathDance workshop. And we have some minutes for Q&A and networking. So if you have any questions, if you have any comments, please ask using your chat, then we will answer. So we have, I believe, around 5 to 7 minutes. Make sure to download the PowerPoint, the slide PDF, and hopefully someone can send me the video with 10 equations. Then, as I announced, I will send a certificate of completion. Thank you for your comments. Gangnam Style, yes, that's another project. Okay, it seems there's no question. So if you have any questions, comments, of course, if you complete the app with 10 equations, please send me the video, or even you can send me just the SBC3 file, and I'll send you a certificate. So, Julius, are you still there?
Hi, CJ, I'm still here, yeah.
Yes, I remember that an organization after school group was asking you to have the presentation for this MathDance. So if they re-ask, then yes, please, teach this MathDance workshop for them.
I mean, your presentation is now in the resources
Yes,
on
yes.
the
Now,
neural network, and it's also on the program page on the AI for Good website. So it's people can find it easily, which is great.
yes.
Thank you. So we
So,
don't have any questions having come in though.
okay. Then,
Oh, sorry, we have one. We have someone who's asking a question. Yes, Sia Burela Masi, you can ask a question. Just bear with me for a minute, CJ, and I'll put the question in the chat.
okay. So please let me know if there's something on your. Oh no, there's not. I don't see the question. Okay. I don't see the question. Julian, did you?
I haven't put it in the chat just yet.
Oh, okay, I see.
Because I'm still waiting to receive the question.
Oh, okay.
Just bear with me for a moment. The question is not coming through, I'm afraid.
Okay.
No, unfortunately, there's no question. They asked whether they could ask one, but they haven't asked one. So I would suggest that we can close now with the video if you'd like, CJ.
Yes, let's close. Thank you, Julian.
Perfect. Thank you so much,
Thank you.
CJ.
Thank you, everyone.
Thank you all.
Thank you for participating in today's AI for Good session. We hope you've learned something new, innovative, and engaging in today's event. We now encourage you to continue the conversation on the live video wall in the neural network. Here you can ask questions, like and comment, share links, complete the poll, connect with interesting profiles, or speak one-on-one using the chat and video function. We invite you to explore the lobby, try the smart matching quiz, visit the virtual exhibits, poster boards, the eShop, and build your personalized AI for Good program. Let's shape the future of AI for Good.
The AI for Good Global Summit, convened by ITU, recognizes the joint responsibility of governments, the private sector, United Nations agencies, academia, and others to ensure AI reaches its full potential while preventing and mitigating harms.
And it's a moment that calls for action. And today I'm calling on each of you to use this summit to help the world to better understand what kinds of regulations, what kinds of guardrails we need to put in place right now. So together, let's make it innovative, let's make it safe, and let's make it responsible for all. Thank you very much.